Hello, guys. So today we'll be discussing a bit about how this whole thing of limit theorem, this thing came into the picture and what's the story behind it. So essentially, the first instances of the idea of limit theorem came around when people were starting to understand central limit theorem. So, or maybe the idea that mean converges to the mean, like the mean of the samples x bar converges to the mean of the, let's say, x on x to xn follows IID some distribution with certain mean. So we know that sample mean may be a good choice for an estimate, right, for the population mean, for an idea. So people are asking, like, how can this sample mean be a good, you know, like, how can you mathematically prove it? So that's when they started discovering that they started to understand the distribution of xn bar, the x bar, the sample mean, and how it's approaching. So it saw that as n is increasing, x bar is actually approaching a certain number. It's becoming constant. Okay, so the question was what it means to be a constant. Uh, so that's where it's the whole idea was, like, you can do this experiment right now that you keep on tossing coin and check the number of heads. The total number of heads by total number of tosses. That's some mean, right? Summation of the Bernoulli by n. Okay, xi follows Bernoulli p. So take this n Bernoulli trials, sum it up. So if it's one, then that's heads. If it's not one, then tails. So number of ones. The sum will be nothing but the number of heads by n. So if you just take this number and increase the n, you will see it approach a certain number. Question is that what it means to approach a certain number, because these are random variables. Remember, it's approaching a certain number. So we have to seek a single or a few, the theory of convergence of random variables. So what does convergence of random variables mean? So in the following lectures, we'll understand what does the convergence of random variable mean. Okay, so what it really means for x1, x2, xn to converge to a certain random variable, another random variable. So seeking that path, like we've already seen this before, that let's say you have seen this, that if x1, x2, xn follows, or rather if you know that binomial, right, the sum of the binomials. Okay, so rather sum of the binomials, I'm sorry, so binomial distribution, uh, where xi follows, let's say xi follows Bernoulli, um, let's say xi follows Bernoulli p. Okay, so sum of the n Bernoullis will follow n binomial n comma p. So we have seen that as n increases and p goes to 0, this n comma with this and n comma p goes to a certain constant. We have seen that this goes to Pointio lambda, right? Where np goes to lambda. So we've already done this idea of convergence before, and we have seen that the PMF of that converges to the PMF of this. So is it true that in like in corresponding random variables will do the PDF, but PDF may not always exist. PMF may not always exist. So what's the general thing? We know the general thing is CDF, right? So what if CDF exists, since we see the convergence of CDF as functions convergence, like individual point convergence? Or maybe there's some other way of understanding convergence. We have seen the same way for hypergeometry, right? In hypergeometry, we have taken certain parameters, and when we have increase the number of sample, the n, capital N, it goes to binomial, right? So I mean, under certain constraints, it goes to binomial. Yes, not capital N goes to 0, but yeah, under certain constraints, it goes to binomial. Question is that how do you mathematically formulate this? So we will see central limit theorem. We will see two types of convergence: convergence in distribution, convergence in probability, and we will see how we can combine the idea, what are the connections between it. And in these two classes, we will see how this the most important result, that is the law of large numbers, central limit theorem. It's law of large numbers telling that the mean is going to somewhere. That's the problem we started with, right? So we will see the mathematics behind it. We will see how it's done, everything, total connection between it. So in this week, we will be exploring this topic and hope you'll enjoy it. And we'll see you in the classes. Thank you. If you have any questions, you can ask us in the WhatsApp group. Thank you.